So what is mean by free form? In general, we can take it as a tree. Three vertices, also sum of its internal angle is nothing but the 180 degree. Polygons means more than 3 sides. Octagon, hexagon, and open figures starting and ending points are different. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics Faculty, Vidhyaashram, Temple of Excellence, Mysore. So in this session, we are going to talk about what do you mean by the shapes. That means the geometry, okay? The shapes are nothing but you know already it will be a 2-dimensional and as well as the 3-dimensional. Where we are going to use these shapes? We are going to use these shapes in where the circle in as well as in the sports also we are going to use the shapes, isn't it? Now what do you mean by a shape? Shapes are nothing but it is classified with the respect to their regularity or uniformity. What is regularity and uniformity? Either it can be a circle or it can be a square, like that, isn't it? So a regular shape is usually symmetrically such as square, circle, etc. And irregular shapes are what? Asymmetrical. Obviously, regular shapes are symmetrical means irregular will be asymmetrical shapes. And they are also free form of shapes or the organic shapes. What is mean by free form? In general, we can take it as a tree. Correct na? So that see the shape of a tree is irregular or organic. Okay, in nature also we are going to see such type of shapes. Next we are moving on to in a plane geometry, there are two types, that is 2-dimensional shapes and 3-dimensional. And 2-dimensional shapes are nothing but they are flat and then closed figures such as circle, square, rectangle, rhombus, etc. Kite, you can take all those things, isn't it? In solid geometry, the 3-dimensional shapes are cube. That means 3-dimensional means it will be expressed as what? You cannot, the other face cannot be seen. The backside face cannot be seen. That is nothing but the 3-dimensional. The examples are cube, cuboid, cone, sphere and cylinder you can take, etc. So in daily life also we can observe those kind of diagrams or the figures, isn't it? We'll move on to next. What is the definition of a geometrical shapes means? Geometrical shapes are the figures which are represent the form of different objects. In day-to-day life, you are going to see different kinds of object. That representation is nothing but the geometrical shapes. Okay. Some figures are 2-dimensional and whereas some are 3-dimensional. As I told you, the 2-dimensional diagrams also will be there. 3-dimensional diagrams also will be there. What is the difference? Dimensional diagrams can be seen or can be, you can write it on a board clearly. But 3-dimensional, you are only writing the first face. That's it. The backside face cannot be seen, isn't it? The 2-dimensional figures lie on only where? In x-axis. This is called x-axis. X-axis and then it can lie on the y-axis. Y-axis means vertical line. This is called y-axis. Okay. The 2-dimensional diagrams. And as well as 3-dimensional shapes lie in XYZ axis where a Z axis shows the height of the object. It will showing the height of the object. So you can have it as in the diagram if I want to write it as this is X, Y and Z height. So this is the X axis. You can write it as and this is nothing but the Y axis and this is nothing but the Z axis. Okay. This is how we are going to represent the 3-dimensional axis. Okay. Next, we'll be moving on to what are all the types of the and properties of the geometric shapes. Okay. Here I have taken the 2-dimensional. You can see here. First, I have chosen the triangle. Triangle is what? It is a polygon. Correct? Na? Polygon means more than 3 or 2 sides it will be. Polygon which is made up of 3 sides and consists of 3 edges. 3 edges. These are all 3 edges. Correct na? And 3 vertices. Correct na? 3 vertices. 3 vertices also sum of its internal angle is nothing but the 180 degree. This is a basic you need to know. And circle. Circles is a locus of all points at a fixed distance from a reference, a central point. It is a fixed distance from a reference to a central point. This is a fixed distance where this is going to be known as the radius of the circle, and the center, which is nothing but the 2 times of the radius, is nothing but the diameter of the circle, isn't it? And circumference of the circle, you know, 2 pi r. Next, we'll be moving on to the square. Square is a quadrilateral where all the 4 sides and all the angles are equal. See, you can observe all this side is equal to the same, this side and this side. All the 4 sides are equal, and the angles at all the vertices equal to what? 90 degree. That means this one you can observe, this is a 90 degree or this is a 90 degree, correct na? That you can observe that the angles will be, vertices will be, what is that? Equal to each 90 degree. Next, we'll be moving on to the rectangle. Rectangle opposite sides will be equal. It is a quadrilateral which has 2 pairs of opposite, 2 pairs of, this is one pair, this is one pair, and this is another pair. 2 pairs, opposite sides equal in length, and interior angles are at the right angles. Interior angle, this one, interior angles are at the right angles, you can observe. Next, we'll be moving on to the parallelogram. Parallelogram is a quadrilateral with 2 pairs of parallel sides and opposite angles are equal in measures. 2 pairs of parallel sides, isn't it? And opposite in measure of an angle, right? This is a parallelogram. Next, we'll be moving on to the polygons. Polygons means more than 3 sides. Octagon, hexagon, that are going to be known as the nanogon. All that are going to be known as the polygons. Here I have taken the 6, 1, 2, 3, 4, 5, 6, which is a hexagon. So these are made up of a line segments and no curves will be there, and they are enclosed structure based on different length of a side and different angles you are going to have it as. That is nothing but the polygon shape. Next, we'll be moving on to what are all 3-dimensional. Most of 3-dimensional shapes can be defined as set of vertices, set of lines that connect the vertices and faces enclosed by these lines, including obtain the interior points. The polynomial function is a quadratic if the degree is 2, and if the degree is 3, it is a cubic, isn't it? Here I have taken some shapes which is nothing but the cube will be like this, and next we have taken cuboid and then cone. All these are, see, you cannot see the other face, correct? Now backside face you cannot see, that is called the 3-dimensional. Okay, next we'll be moving on to the cylinder. See how nice. And then spear you are going to have, which is a globe, you can take it as, isn't it? Or a football, volleyball, throw ball, all that will be considering as a spear shapes. Next, we'll be moving on to the open and the closed figures. What do you mean by the open figure? A point is a small dot which is starting point of a line. This is very important. Segment. By definition, a line segment is a part of a line which is a narrow lane in connecting 2 points, with the same line. If you start, it will be getting connected to the same point. That is going to be called as what? A point of the that. Different numbers, line segment gives us different figures. Such figures may be either open figure or closed figure, or shapes you can take it as. If you start at one point, if you are going to close at the same point, it is a closed figure. If you start at one point and no exit point will be the same point, it is nothing but the open figure. Next, we'll be moving on to what do you mean by the closed shapes. Geometric shapes such as square, as I shown you here, correct na? A rectangle, what is a square? Rectangle, this is a square, this is a rectangle, isn't it? And triangles are few basics 2-dimensional shape which is nothing but the closed. These figures are collectively called a polygons, more than 3 sides. So a polygon is any flat made up of a fixed point, correct na? Or a shape or a plane on a surface of the paper. You can write it on a paper or a board, isn't it? They have finite closed boundary. Once if you start, it will end in the same point. Okay, made up of a fixed number of line segments and are called sides of the polygons. Each side meets at a common point. You can observe, called as the corners or the vertex. Common point it will be meeting each side, that is going to be known as the vertex or the corners. Such bounded geometric shapes like polygons are called closed figures. A boundary of a closed figure is not only made up of a line segment but also the curves, and hence closed figures can be defined as any geometric shape which start and end at the same point. As I told you, it will be starting and ending at the same point. Are you getting? Even in the construction also you can use that one. If you want to construct a wall, you are going to start at one point then end at the same point, isn't it? That is also a closed figure, right? So next we'll be moving on to the open shapes. Open figures are incomplete shapes. That means there will be a starting point but don't know where the ending point will be, isn't it? Or it will not connect to same starting point. That is going to be known as the open figures or open shapes. To sketch a closed figure, one has to meet both the starting point and the ending point, as I said to you. But open figure are also depicted by using line segment only, or by curves, but at least the lines will be discontinuous, as I told you. And open figures starting and ending points are different. Like this you can have starting and ending point will be different, and this will be having, see, these are all going to be known as the open figure. Correct na? So starting point will be there, but no ending point you can have in that one. Anything ending point, it will not connect to the ending point. It will be having ending, but it will not connect to the same starting point. That is going to be known as the open shapes. Thank you. In this session, you understood what do you mean by the shapes, geometrical shapes of the two-dimensional. These we are going to study, these areas and all we are going to use it in first PUC basic mathematics when comes under the geometry. So hope this session was good. Thank you dear students. We'll meet in the next session.